Hey y'all, Matt, Dlux, DluxFab.com. Today we're going to talk about gearing. Now for the following discussion, we're going to talk mostly about axial based axles. So these are gears that you would use an AR-44 style ring and pinion. So that could be your AR-44, your F10s, your SSD Luxes, your DX44s. That small ring and pinion gear design is pretty hard to beat. There's three sets of ring and pinion gear you can get for axial. You got underdrive, your standard, and your overdrive. Now for your underdrive ring and pinion for your axial AR-44 style gear set, that's a 33 tooth ring with an 8 tooth pinion. Final drive on that is a 4.125. Your standard is a 30 tooth ring with an 8 tooth pinion with a 3.75 ratio on that. Your overdrive is 27 and 8. That's a 3.375 ratio. Now those are standard. There's some outliers. I know Odd 6 has got one that's different. But there's your basic ratios we're going to start with. Now, for your portal gears. Now, these are axial style. Your stock portal gears, the 12 and 23. That's a 1.91 reduction at your portal. Oh, your overdrive portal gears are 15 on top and 20 on the bottom, as they are in the gear, as they are inside of the housing. That's a 1.33 final reduction. So those two are a 36% difference just in the portal gears. Now that's using any of these ring and pinion gears. So given my druthers, I would use underdrive front and rear, and then get the standard rear portal, overdrive front portal to get that gear ratio in those axles as low as possible. The lower the gear ratio in the axles, the less effort it's going to take for the motor and transmission, that torque, to make forward motion. Today we're talking about gearing, how to figure it, how much gear reduction do you need, all that fun stuff. A lot of people understand how to do the simple math, but they don't understand the process of how to get to where you're going, all that fun stuff. So when you're talking about gearing in these RC trucks like we use for crawling, we're going to start with basic stuff. So you want to figure out your gear ratio. You know, it's how many teeth are on your spur divided by your pinion. That's where you start. You multiply that times the internal gear ratio of your transmission. We're going to call that internal gear ratio. So it's where we're going to start with, just for example, we're going to use a portal transmission. Those have a 36 tooth spur. We're going to say a 12 tooth pinion, just for example. So you divide those two. That's 3. Now, times internal gear ratio. The internal gear ratio of the portal transmission is 3. So 3 times 3, that's 9. So that's your, with a 12 tooth pinion in your portal gear transmission, portal transmission, that's 9 to 1. That's your transmission gear reduction. So now you're gonna multiply that times your ring and pinion, and your AR-45 portal, your capper portal, your ring and pinion gear is going to be 30 tooth ring gear an 8-tooth pinion. So 30 divided by 8 is 3.75. So 9 times 3.75, 33.75. Now that's before your portals. The 33.75. Your stock portal gears are 23 and 12. So 23 divided by 12 is 1.91. So you take your 33.7. That went well. So you take a 33.75 times 1.91, and that gets you a 64.96 final drive ratio. Put for you 0.46. 64.46 final drive ratio with a standard portal gear. Now, if you go with an overdrive, you want to figure that overdrive ratio. So you take a 33.75, you multiply that times your 20, 15 are your regular portal gear, or your overdrive portal gears, right? So that's a 1.33. So 33.75 times 1.33 equals 44.88. So that'd be your rear ratio, that'd be your front. Saying you're running regular portal rears and overdrive front. Now that's a 36% difference. Now, calculating the difference in the percentage of one number versus another is kind of complicated. I'm not going to try to explain that here. I will attach in the description below a percentage difference calculator to figure that out. So that's more or less what you could expect. That's how you figure your gear ratio with the portal gear. Now that's based on the portal transmission. Now what we're going to do next is we're going to clear all this. So we're going to do it for the nod. So on the nod, you have a 44 tooth spur. We're going to stick with a 12 tooth pinion. So that's a 3 point, that's that reduction. And then the internal reduction for the nod is a 4-to-1. So 3.66 times 4-to-1 is a 14.64 ratio. So that's with a 12 tooth pinion. That's your transmission reduction in the nod with a 12 tooth pinion. 44 divided by 12 equals 3.66. 4-to-1 internal gear ratio. So 3.66 times 4-to-1 equals 14.64 to 1. You take your 14.64 and figure it times your axle gears. So with a standard, so let's start with underdrive actually. The underdrive gears are 33 ring at the 8 pinion. That's a 4.125 reduction to the rear. So to break that math down, your 14.64 times your 4.125, that's a 60.39 final drive ratio. So 14.64. Now your standard gear ratio is a 30 and 8. So you can divide that. And that's a 3.75. So 14.64 times 3.75 is a 54.9 final drive ratio. Now with your overdrive gears, take your same 14.64 because your transmission hasn't changed, and those have a 27 and 8 ring and pinion. Now that's a 3.375 axle ratio. So 14.64 times that 3.75 axle ratio equals you a 49.41 final drive ratio. So that's under, standard, overdrive. That's how you figure that. So if you use an underdrive rear and a standard front, underdrive rear, standard front, that's going to get you a 9.5% overdrive to the front. So an overdrive front and a standard rear get you 10.5% overdrive. Now with underdrive and overdrive, these are axial based AR44 style axles. That's 20%. So now that's how you break it down on the nod. Now we're going to break this down on the OD3. So the OD3 has a 44 tooth spur. We'll use a 12 tooth pinion just to make this math easy. That's 3.66. The internal gear ratio on the OD3, funny enough, is 3.66 to 1. So that equals a 13.39 ratio from your transmission. Drive gear ratios at your axles. We're going to take our 13.39. The underdrive gear ratio for an axle ring and pinion underdrive is a 4.125. So 13.39 times 4.125 is a 55.2 3 to 1 ratio. That's with underdrive. The standard, take a 13.39 times 3.75. That's going to equal a 50.21 ratio. I know some of this is repetitive, but if it's repetitive, you'll remember it and you'll know how to figure your gearing. Now, with overdrive, ring and pinion, that's a 13.39 times a 3.375 ratio. That's going to be a 45.19 to 1 ratio. Right now, the OD3 has 18.6 under to the rear. So if you combine all this with the same ring and pinion gear, whether it's under, over, or standard, with the same ring and pinion gear, front and rear, you got 18.6% underdriven at the rear. Now, if you add an underdrive rear, so a standard front, UD rear, you're looking at a 28% difference front to rear. So with underdrive and overdrive, that's a 38% difference to the rear. Now, A lot of that's pretty standard and kind of repetitive, but I get a lot of questions concerning how to figure this. Of course, this will all break down, it'll all change based on your pinion size. But that's a quick overview on how to calculate your gear ratios and know where you stand. Any questions or comments or whatever, put them down below in the comments. We can discuss it. Thanks, guys. Have a good day.